Hey everyone! For my team's project, we decided to develop a question answering model. Initially, just to test the submission process of the model, we used the Google T5 system, which had 220 million parameters. We realized that this model's confidence and answers were suboptimal due to its smaller parameter size and its less extensive training data. In general, we use this as a tool to get familiarity with Hugging Face's pipelines and running models in Google Colab, but it was a good insight into the models that we needed to select in the future. So to take this information, we decided to use the pre-developed models from Hugging Face for the sake of efficiency. We explored various much larger question answering models on Hugging Face and decided to select the Llama 3 ChatQA 1.5 8B model for its balance between efficacy and processing time. This model has 8 billion parameters and was developed by Meta and optimized by NVIDIA for the task of question answering. We tested this model using questions from the quanta.buzztrain dataset to verify its accuracy. After doing this and realizing that this model was effective for answering our questions with an acceptable level of confidence, we decided to add more context to the questions that the user asks. Given the database of questions and answers that we had, we decided to create a vector database with the data from quanta.buzztrain. We converted each training example into a vector using the BERT model developed by Meta and stored it in a Parquet file. Then we developed a separate file to take in a query, convert it to a vector, and search the database. This query is the question that the user passes into the Llama 3 database. So essentially, when the user asks a question, there is additional context provided to the model about that question that is generated from the quanta.buzztrain dataset. We then pass these results into the Llama 3 model for this additional context. After developing and using this model, we implemented a pipeline to interface with Hugging Face. We tested our selected model to determine the input and output requirements, and then we implemented Hugging Face's specific pipeline methods: sanitize parameters, preprocess, underscore forward, and postprocess. Preprocess prompted the model with the appropriate role for Quiz Bowl. The forward function passed the query and instructions to the model, and the postprocess function extracted the output and calculated the confidence. We then pushed the pipeline class to Hugging Face and pulled it back into the notebook and performed a sanity check with a sample question from the quanta.buzztrain dataset just to see how well it worked. And our model worked perfectly.
So I'll be talking about our delegation of labor. So in our initial phase of the first 2 weeks, Akash and Akhil initially used the OpenAI servers to create embeddings, but then as a team we realized that the lack of internet access would be an issue, which led to Kito and I then implementing a local solution using BERT, and we updated the team on our progress. And then finally, Rohan and Srivishnu created a file to find the closest matches using cosine similarity. So during our second phase, of the project, Akash, Akhil, and Kito became our Hugging Face experts, and they learned how to use the platform and upload models as well. And then they taught those skills to me, Rohan, and Srivishnu, where we then explored the different question answering models on Hugging Face. And then as a team, we selected the Llama 3 question answering model as our best option. And then Kito and Akhil worked on converting that model into a pipeline for the Hugging Face platform and implemented the vector database. So finally, we all contributed in writing the report. Akhil, Kito, Akash, and I recorded our team's video, and then we put it together. So some challenges that we had were figuring out how to convert the Hugging Face model into a pipeline for submission, because we had never used pipelines before, so it was difficult to learn all those different methods and commands required for it. And then another challenge was finding a way to vectorize the data offline. Many of us had used APIs for OpenAI for embedding, so it took a lot of research for us to find our BERT model.
Okay, so overall, our model did pretty well in comparison to other teams. We received a buzz confidence of 18%, which was top four on the leaderboard. On top of that, we were also selected to represent the computer team during the final showdown against the humans. Now, in terms of actual error analysis, some things we noticed were that firstly, um, It did pretty well with fact-based questions, mostly because fact-based questions are very clear-cut and have a subjective answer, which is really easy for a machine to answer. Um, but in terms of subjective questions, the machine struggled a little bit here because I guess subjective questions like pop culture and film are just better suited for humans because there's just better at reasoning and also they understand the nuances of certain references. Now, in terms of confidence, we noticed that the confidence increased as more of the question was revealed, which is pretty intuitive because you get a better idea of what's being asked. And then we also noticed that sometimes the model provided timid responses. Sometimes it responded that it needed more information to continue on. Now, moving on to some actual examples in the data set, or I guess the output of the data set. Firstly, a fact-based question that was asked was the artist selected by Eli Broad and David Baltimore to install a zigzag wall on the Pasadena campus was, and in this situation, it guessed Norman Steinloff with a confidence of 0.54. Um, However, the actual answer was Robert Smithson. So um, I guess this kind of shows that the model struggles with lesser known names, which indicates a gap in training data. Now, one example of a subjective question was the character of Larry David in the TV show Curb Your Enthusiasm was, and it guessed Elka um, Ostro Ostrovsky from the TV show Hot in Cleveland. So in this situation, the confidence was also pretty high. It was about 0.75, and the correct answer was Larry David, not Elka. So this kind of shows that it struggles with character recognition and parsing context. I think uh, most like Quiz Bowl players probably could have guessed this based on like context clues and also just general knowledge of pop culture. But unfortunately, the machine doesn't really have that programmed in. And an example of a timid response is the question was, which two artists and which albums are you referring to? And I responded with, I need more information to answer. So in this situation, not much of the question was revealed. So it gave like a really timid response. But the confidence was still pretty high at 0.75. So I guess with some prompting, we probably could address this.
To understand the linguistic motivation for the features, we begin with how we get our word embeddings, and that's through BERT. BERT stands for bidirectional encoder representations from transformers, and what this specifically means is that we examine the context of the word to get the word embedding. And the difference between BERT and general word embeddings is that they usually go from left to right or right to left, and this gives us from one direction, but BERT looks at both the preceding and the succeeding words and gives us a pretty accurate context for a specific word. And this is important because if a word has multiple meanings, we want to narrow it down to a singular meaning that we can use to find the context of the question. And so this is extremely important for questions because if we're given a question that says it's about a specific movie or something, we can see the context of the question with that movie, and BERT can understand that it has this one specific definition. But what we actually do with the word embeddings is we perform cosine similarity, which is something we've done in previous homeworks for this class. And we all know that cosine similarity basically takes the vectors of the words that we embedded and it finds the most similar ones. So since we have such a large frame of reference or like question and answer things from our data set, we can use cosine similarity to narrow it down to the closest 5 to 10 questions based on the word definitions. And we can use those answers to form a better context that our model can base its answer off of. And this actually improves accuracy a lot because with the closest 5 questions and answers to what we're looking at right now, we can form like a really good idea of, let's say if we have a very specific movie or we have a very specific historical time frame, we understand where we are and the model can be very accurate when it's providing the answer.